compound, and in this video we'll be determining the simple or empirical formula of a compound. And so the objective here is that you can write the empirical formula based on either the element's mass that makes up a compound or the percent composition in a sample. So we're going to start off with a couple examples. So real quick, if you know either the mass of each element in a sample, or if you know the percent composition, you're given percent composition of a compound, you can determine the empirical formula. So an example would be if you have a 9.2 gram sample of some kind of unknown, and you know it's composed of 2.8 grams of nitrogen, 6.4 grams of oxygen, you're asked to find the simplest formula. And what I like to do here is if you think of all the things that are made of nitrogen and oxygen, right? We've got N2O, right? This is laughing gas, which is potentially hazardous if you breathe in too much of it. It could be NO2, which is toxic. It's a toxic gas from air pollution. It could just be simply nitrogen monoxide, which is not really harmful except in large doses. It's also emitted by automobile combustion. And then it could also be NO3, which isn't harmful. It's actually used in fertilizer. So there could be a number of different combinations of nitrogen and oxygen. This is important in chemistry because we can actually figure out, well, which one it is and if it's harmful or not. So the first thing we want to do is go back to being able to convert our grams into moles. And so the first thing I'll do is I'll convert my number of grams of nitrogen, which was 2.8 grams of nitrogen. I'm going to convert it into moles. I'm going to divide by the molar mass of nitrogen. So divide it by 14 grams of nitrogen in 1 mole. And if I do that, I should get something around 0.2 moles of nitrogen. And then I'm going to convert oxygen from grams to moles, and I had 6.4 grams of oxygen. I'm going to divide by the molar mass of oxygen. So in 1 mole, there's 16 grams of oxygen. And I get 0.4 moles of oxygen. And the next step that's really important is I'm going to divide the larger number of moles by the smaller one. So in this instance, oxygen is higher, so I'm going to divide 0.4 moles of oxygen divided by 0.2, a little legible, moles of nitrogen. And the number I get is a 2-to-1 ratio here. So 2 to 1, or really 2. So what I do now is write the subscript, or what these numbers mean is the subscript for each of these elements. So there are 2 atoms of oxygen for every 1 atom of nitrogen. So my formula, my empirical formula here is NO2. And then it's always important that when you write the formula, it should depend on which one goes first on the problem, but write the formula as how it's actually listed in the problem. So that's one way of finding the empirical formula. We just found NO2. The other way is if we're given percent composition. And in this instance, all we need to do is think of our sample. And let's just imagine we're just going to use a 100-gram sample. So when we do that, all we need to do is flip these percents into grams. So we're still going to do the same exact thing, except when we have our percent, we're just going to flip it to grams because we're going to imagine we have a 100-gram sample. So there is 65.2 here and 34.8 here. And I'm just going to do the exact same thing I did before. So I'm going to convert grams to moles. So here I've got 65.2 grams. I'm going to divide by the molar mass, which is 75. The mole goes on top. Grams cancel, and I get 0.870 moles of astatine. And then I'm going to do the same with oxygen, so I've got 34.8 grams of oxygen. Divide by the molar mass, which was 16 grams. Oxygen in 1 mole. Grams cancel. And I get 2.18 moles of oxygen. My next step, if you remember from the last, is to divide the larger by the smaller. So oxygen is going to be on top this time, so we've got 2.18 divided by 0.87. And the number I get is something like a 2.5 to 1 ratio. And what we should notice is, can we really have half of an oxygen atom? And the answer is, well, of course not. So what we do is if we're going to find really the least common multiple here. So what we're really going to do is just multiply, just a quick fix, multiply each thing by 2. And if we do that, we get 5 atoms of oxygen for every 2 atoms of acetine. And so our answer is going to be As2O5. So again, make sure that if you have a number that's like 2.6 or 2.4, if it's around the half point, just put it at that half point and then just multiply it to get your final answer. So that is finding the empirical formula. Thanks for watching.